So, good evening, everyone. My name is Riya Sharma, and I'm a PMRF scholar from IIT Kanpur. I'm a PhD student, currently in third year in chemical engineering branch. I will be taking the week 6 lectures of fluid phase and thermodynamics of fluid phase equilibria. All the past 5 videos we have already uploaded, as well as the notes has already been given to you. So we will be starting ahead with week 6. I'll be giving 1-2 minutes, let others join, and then we will start recording the lecture. I'm so sorry, my throat I have throat ache. This is week 6. The course is so so these are like big questions. We'll be taking I have 10 to 15 questions, but we will be starting with basic concepts questions and few like going ahead with it, and then we will end it up with taking some numerical problems and containing it by that. So let's start taking the first question. I have my own questions which I'll be writing out, and that you can start it with me. There are some network issues, so for the time I'll be writing the questions, I'll try to switch off the camera. But by the time when I'm interacting, and if you have some questions, I'll be taking those questions as soon as possible with the camera on. So for that thing, I'll be switching it off. And yeah, if you have any doubt, you can interrupt me anywhere in between. So you can start writing the question. Question number 1. So it is saying, for a Gibbs-Donan equation, the initial concentrations are solution 1, that is an alpha phase, 3 millimolar per liter NaCl, and solution 2, beta phase, 3 millimolar per liter NaP. The membrane is impermeable to P. Assume equal volumes and that the pressure necessary for concentrations of the ions in moles are. So this is our first question. So what it is given, you can just start thinking about it. What it has been given to us, that the initial concentration is 3 molar NaCl and the 3 millimolar NaP, so that is equal molar. So one thing is given to us, it is impermeable. It is saying it is equal volumes. So it is asking the pressure necessary for the solution. Sorry, that so some issues are here. I think so we have to do. I think I was thinking. Yeah, the pressure is necessary for osmotic equilibrium is applied. So there are not water fluxes. The equilibrium concentrations of the ions in moles are. So what they are asking are the equilibrium, so osmotic equilibrium is applied. You can try solving this question. I'll be giving you 2 minutes to solve these questions. So you can understand this, that there is a membrane where there is an alpha phase and there is one beta phase. So I have named that as 1 and 2. So since there are ions, one is NaCl, the other is NaP, the there will be few ions which will be moving from 1 to 2 and there will be few moving to 1, like wherever the concentration, like from more concentration to less concentration, there will be a movement. And they have already told us one assumption. So this is a solution. So they have already told that assumption which is necessary to understand that osmotic equilibrium is there. Osmotic equilibrium pressure is already applied. So you don't have to apply some extra pressure to make the movement of ions. So this has already been there. So let us assume, so to start this again, let's assume X be the number of moles that move from 1 to 2. So initially they were at equilibrium. So like there will be some part, if I'll say that there will be one concentration of Na, there will be one concentration of, or you can say that. So these are things which are already present. So what they are telling us that the P part is impermeable. Okay, so there is no permeable of Na. So only there will be movement of NaCl. So there is already Na, and there will be a movement of NaCl from somewhere. Like they will be moving. Only P part of it is impermeable, right? So you have to understand that in alpha phase, beta phase, there will be now some movement there. So there will be NaCl, Na in beta phase and chloride in beta phase, because P is impermeable. So this has already been given. So let we assume that there is a movement of X. So it was given that 3 millimoles were already there. So initially there were 3 millimoles per liter. So I am assuming that there were already 3, and there is a movement from 1 to 2. So let us say that X moles have moved. So this will be 3 minus X, 3 minus X, and whatever has been gone, it has been gone from this part. So in beta phase, basically in second phase, there will be an addition part of it, right? But at equilibrium, like after everything has happened, at equilibrium condition, Na alpha concentration multiplied by chloride concentration will be equals to Na at beta phase concentration at chloride at beta phase concentration, right? So what we will write, this will be 3 minus X, 3 minus X, and X has only come because no Cl was initially there, right? So just understand this thing. So Cl has already came, but already into x. So if you'll multiply 9 plus x square minus 3x minus 3x, right? The 3x plus x square. So I'll be taking x square to x square cancel. It will be 9 x equals to 9, which implies x is equals to 1. So the basic assumption which was there, that assume equal volume. So the equilibrium concentration will become of Na in alpha phase will be 3 minus x will be equals to 2 mole. Cl alpha, it was 3 minus x, will again be 2, and Na beta will be equals to 3 plus x will be equals to 4 moles, millimoles or moles per liter, or 4 molality we can write. Cl beta will be equals to x equals to 1 mole. So if I'll write in answer form, so this will be the answer, that Na and alpha will be equals to 2m, fluorine and alpha is equals to 2m, and beta phase is equals to 4m equals to 1. This is the answer to our problem. Are we good to go? You can just say it was basic, but there were few things which has to be taken account so that there won't be any problem. So there were like few things where assuming few things to be not moving, and then we just have to do the Muller balance and we are good to go with it, right? Okay, so let us move to our question number 2. So this is a conceptual question. There's nothing there, like it should be known for Donham equilibrium condition in very dilute solution, activity of solvent is 1, then the activity of solute is equal to so this you should there when the activity is equals to 1. So when solvent activity, this to be remembered, is 1, there the solute activity is equal to the concentration. This you have been already done in lecture 2. of week 6. So I'm not re-emphasizing on it, but this should be remembered. Now question number 3. Okay. Okay, this it's a good question. Like, what is the more studied? You should know these things. Potential models. For fluids. So there are different potential models, but Lennard-Jones potential model is the most studied one. Is the most studied one. So taking one question of yours, this of your assignment, so that you can revise. So taking question number 1 of your assignment, if you know that question, I won't be writing everything of that question, but assignment 6 question number 1, where it was saying if Lj, so I am just saying Lj here. Okay, if Lj is used for determining potential between two non-polar, so that we can spherical atoms, then at what distance the force between them is 0. Right? So this was the question. So this was the question. If you want, like I just wrote. So this is like if LJPM, if we'll name that as LJPM potential model has been used, so what will happen? So I hope you must have done this, but I will just solve it for you. So as we know, the LJ potential model, what is the value? How we solve that? Sigma by R to the power 12 minus sigma by R to the power 6. Since we know that force, you should remember that is the first derivative so this is, so we need to find R when F is equals to 0. This is the question basically. So what we will do, let us find we need to put F equals to minus dur by dr equals to 0, which will be equals to, so if you do du by dr, so there were, so 4 epsilon was already there. So you are already at 2 sigma r 12, so it's already there, r minus 12, and here sigma to the power r minus 6 is already there, right? Right. It was already there. We need to do d of this by dr. Okay, and the negative side. So negative is not needed. So we need to do this. Okay, I have write it in this form. So which will be equals to, if I'll do a 4 du by dr is equals to, so if I'll do 4 epsilon, I'll put it here itself. I'm putting, so so this will become minus 12 into r minus 30 minus sigma 6 is already there, so this will be into minus 6 to r minus 7, right? So I'll take 6 common and r once here, so this will be equals to, if you'll see, 2 sigma by r 12 minus sigma by r 6 equals to 0. So we want to put du by dr already equals to 0, right? Is it fine? So now, so this part will go 0. So if I'll just have sigma by r to the power 12 is equals to sigma by r, this will go here, so only we will be left with that. So what value of r we will get? So we need to find r value. So this will be sigma by r 2 by 6 equals to 1. So it will be 2. Therefore r will be equals to 2 1 by 6 into sigma. This always you should remember, that there will be one point. So if you want to mathematically see that, so if you remember that for anything this is the point, so where the du by dr is the minimum potential, there will be du by dr, that value is basically, they will ask the u minimum where force is equals to 0. Okay, are we in line? Yes, I guess so. Okay, do you want me to solve any of your assignment question? That, so this we have already done. Let's take another question. So one more conceptual question we can take. For Donin equilibrium condition in very dilute solutions, activity of solving. No, this we have already taken. I'm so sorry. I have already taken this question and I'll take another one. In order to observe the solubility of dense gas mixture, it is important to include the correction terms because so while we when we take so when we use when there is a dense gas, because when we say there's an ideal gas, we assume that the particles are very far from each other and all that. But why we have to include the correction terms? Because it will capture the non-ideality. Okay, so like there's interaction between them, like interaction, van der Waal, electrostatic, even volume correction term, pressure correction term. So this when we not taken in ideal gas, but in reality we have to capture those things, so that's why we take the non-ideal or the ideal picture of it. I hope everyone we are in line with it, right? Let's go and take few questions more. So let's take another question. It says the pressure is calculated by using the video equation as 4.80 atm for 1 mole of carbon dioxide CO2 gas contained in a volume of 5 liter at 300 Kelvin. Calculate the second Barrier coefficient in centimeter cube per mole. So there are A 126, B is 132, C is 154, D is 222. So you can try solving this. I'll give you 2-3 minutes to solve this problem. So I hope you must have tried something, and we'll start solving the question. So the pressure is calculated by Wheeler equation as 4.8 for 1 molar of carbonate contained in a. So we have been given I'm sorry. So as we know the expression already, so what we has been given, so first of all let me just write. So what we has been given to us is T equals to 4.8 so 4.0 atm. We also know that Vm, so 5 liter in 1 mole is equals to 5. For 1 mole of carbon dioxide gas content. So it is saying for 5 liter like molar volume, it has been mole inverse. Calculate the second variable coefficient. So temperature we have already been given to us. The temperature is 300 Kelvin. So the basic thing for CO2 gas we has already been given. Okay. So what they are asking, calculate the second variable location. So we should know that what is it? The variable coefficient. This equation we should know, thus it is 1 by Vm plus C by Vm square. So what they are asking us, so we will do what we will do using the above equation, but only involve taking terms up to the second variable coefficient be given as so what will our equation will become? So it will become PVm by RT equals to 1 plus B by Vm. So this basically we don't have to. So this we have to not take. Okay. So what we will do, we need to calculate B basically. So let me write in this form. RT by Vm equals to 1 plus B by Vm. You just have to incorporate all these things. 4.8, 0.082 into 300 by Vm equals to 5, 1 plus B by 5. So and you can multiply this by 5, so it will be minus 5 is equals to B. So you can take a minute to, but this we are doing in, so remember we are doing in liter per mole. All these answers, because we are taking 5 liter per mole, 5 liter per mole. So whatever the answer will come around, like B equals to, my answer is coming around mole inverse, because everything was in liter and mole. So 1 liter is equals to 1000 centimeter cube. So B is equals to 126 centimeter cube per mole. This is our answer. What answer will it be? It will be A option. So that was a good catch. Okay. You can ask the doubts if you have any. So now let's take some questions. At 30 degrees Celsius, the solubility of ethane and acetylene in N-octane are about the same. However, at the same temperature, the solubility of acetylene in dimethyl formaldehyde is different. What could be the possible reason for that? For it. So hint is use the knowledge of intermolecular force. I'll give you options also for this. So let's write the option. Now first is acetylene has acidic hydrogen atoms. B is ethane has acidic. no acidic hydrogen. D is none of the above. So think about it. So the answer for this is C2H2, that is acetylene, has an acidic hydrogen, while ethane does not. Acetylene can therefore complex with DMF this is dimethyl formaldehyde, explaining its higher solubility at same temperature. And no complex occurs with octane. So the answer is A. Got it? Let's do some like these questions where we will take good concepts of these formulations. 8th, So another question is, for large molecules in solution, osmometry and light scattering provide information on intermolecular forces. Through the options are chemical force, B is potential moment force, C magnetic force, D is none of the above. So this you should means it is for learning only, so that's why I am not saying that you should know this, but you should learn this, that it is a like potential of mean force, PMF, what we say. Osmometry, like scattering, is the answer for it. Okay. Another question. Let's take. The assertion that all fluids having the same eccentric factor have the same reduced temperature TR and reduced pressure PR is given by which theory? So this you should always remember this, that which theory gives the, since this is talking about same reduced temperature PR and TR, so answer is it's a 3 parameter corresponding states theory. So take 2-3 minutes of time to go through it. It was given in your lecture 3 to understand what is it, like CH and GM. So these were like the basic question we should always know. Yeah. So after, if you have revised all these things, let's go to good two questions which I really, which are like great questions. Honestly, they will help you to solve numericals a bit better, and it will give a great insights about your things. So let me write those questions. So, experimental studies for a simple non-polar gas A indicate that when two molecules of species A are 1 nanometer apart, the force of attraction is 2 into 10 raised to the power minus 8 die. Consider now two simple non-polar molecule of species B. When these two molecules are 2 nanometer apart, what is the force of attraction in die? Consider the general function to be Lennard-Jones Wilczek's potential. Critical data for A and B are Tc in Kelvin, Vc in Kelvin. Is to 125. So this has been already given to you. I'll Okay, fine. You have to find the answer, so I'll give you some options also. B is minus by minus 10 time. These all are in time. C is 2 into 10 is minus 10 time. And D is 4 into 10 is to the minus. You can once attempt this question. It's a good question, honestly. You can like just see. You can go through the question and then we'll start it. Yeah. So starting with the question. So there you are giving two non-polar gases, A, A, one nanometer apart. So the force is there. Consider two non-polar gas species B. What is the force? So it is saying that there are two more non-polar gas which are there. So as we already know, so let us just write. Let us write what is Lennard Joule potential. So what is Lennard Joule potential? Yeah. minus okay, so this has already been given to us. So what are they asking us to say? So they are saying when there are two molecules of A and A are 2 nanometers apart, then force is equals to minus 2 into somewhat like that 2 into 10 raised to power minus 8 time 10 raised to power minus 8 time. So this is the force which has already been given. Okay, so now they are asking, now there are two another one whose parameters are given. What is the force? D is equals to given. So there are TC and VC values of equals to 191 Kelvin, VC equals to 99 cc per mole, and here it is TC equals to 300 Kelvin, VC equals to 125 cc per mole, right? So it is asking us these things, and they are already told us that use 12.6 model, so we are already using it. And there are few concepts which we have to start with, which we have to use, so we will start that with. But let's first write from LJ potential mean force model. Attractive potential is equals to minus 4 sigma, yes or no. So I am just making that as a gamma function. Okay, so what they were asking, because they are saying force of attraction, so this is the force of attraction, so you should know that there is a force of attraction which is happening. So only we have to take the force of attraction term. This part is attraction and this part is repulsion. So this is very important, that which part to be taken up. So now attractive force is equals to minus D. So now this is for A we are doing. dr, which is equals to minus 24 epsilon sigma by R7, right? Okay, so now we have to think, since attractive force is equals to minus 24 epsilon sigma 6 by R7, assume force of form force equals to minus D gamma by D R is equals to So this value we can take as constant. We just have to into some epsilon by k form we can take, and this we can take sigma by r, right? So nothing what we did is nothing but we have taken a constant, we have taken a sigma by epsilon by k form, and this same form we are trying to transfer it up. Okay, now what we will do, using corresponding states theory, epsilon by k is equals to constant into Tc. So let us assume this as alpha into Tc. So this is our first equation. Then using, so this is for critical temperature corresponding theory, for critical volume, what will be happening, that sigma 6 is equals to constant into Vc square. So this will be equals to constant square into Vc square. I'll say this to be beta into Vc square. So now I am writing where alpha and beta are universal constant. Now we don't have to do anything, we just have to. So now force A will be is equals to, we just have to divide force A by force B. As we know, force was constant into epsilon by k of A into sigma A by Ra7 divided by constant into sigma epsilon by k into B into sigma B 6 divided by Ra B plus 7. Yeah. Now, since we know, so this was our from equation 2, from equation 1 and 2, we can replace sigma k and sigma 12, right? And we already know this is 2 into 10 raised to power 3 force of B is equals to, so we know already constant by constant will cut, alpha into TCA divided by alpha into TC of B into beta into Vc of A square divided by so when we know RA is equals to 1 nanometer apart, so it is 1 nanometer apart. So for RA we knew already RA equals to 1 nanometer apart and RB was 2 nanometer, right? So no, this was actually 1 nanometer apart. Okay, so this was our RA, this is our RB. Got it? So nothing we are doing, we are just putting those value. So this is by beta into VCB by square into RB to the power 7. So since we already know this values, FB I am writing, so this will become TCA by TCB equals to into VCA by VCB square into 2 into 10 raised to the power minus 7 into 1 raised to the 10 7. Now you should know the values of F2 into 10 raised to the power minus 8 by FB. Let's write the TCA and VCB. 191 by 300. So this will be 191 by 300 into VCA by VCB. Let's see. 99 by 125. Into 7. So you can take all these terms into square into 300 divided by 191 into 99 square to raised to by 7. You will approximately get 2 to 3 minutes to solve this question. Yeah, so this will be approximately equals to minus 4 into 10 raised to the minus 10 dyne, which is option B. Let us write another important question that I'll take it as question number 11. Now that is also a good question. Consider a container of fixed volume V, temperature T, having N1 moles of gas 1. We now add isothermally to this container and 2 moles of gas 2, and we observe that the pressure rise is dT. Assume that the conditions are such that the volumetric properties of the gases and their mixtures are adequately described by the Villiers equation, neglecting the third and higher coefficient. The second coefficients of pure gases are known. The expression B12 will contain which of the following terms? A part is B11, B part is B22, C is both, D is none. So this is a good question. So what is saying? It is saying that there's volume T and 1 moles are there. So the isothermally you add N2 moles of gas 2, and there is a pressure rise of dP. Assume that the volumetric gases and their mixture are adequately. So we use Villiers equation, neglecting the third and higher coefficient. So A, B, C you take. The second Villiers coefficients of pure gas known. So now you have to ask B12 will contain what? So you need to find out what will be the B12 gas. Okay. Let us start solving. You'll understand the question. So what is given to you? So we have been given a few things, that is volume, temperature, N1 of gas 1. Then we are adding isothermally, like T constant, that says and 2 moles of gas 2. So there's a general rise of Tp. So basically what will be the P12? So to solve this, what we should do, so what we will do, let the initial pressure be P1, that for N1 moles of gas 1 at constant T and V. So they are saying, so first of all, you should always think, okay, fine, that there is a box of gas where there is gas 1 which has something, it has an T, V and P1 temperature. Okay. Now as we know, since virial equation till second term we have to take. So it will be general will be this, and plus Ij. So for gas 1, initially it will become P1 V by N1 T is equals to 1 plus N1 by V B11. Okay, so let's write in P1 terms. So P1 will be equals to N1 RT by P1 plus N1 square RT B11 upon V square. Now we will say, let the final pressure be P2. So after addition of N2 moles of gas 2 at same T and V, P2 will become, so this will be the similar way, N1 plus N2 moles. Let me write like this, total moles equals to N1 plus N2 interaction whole we are writing as B, which will be equals to, which will be a dependent term on N1 and N2 basically. Okay, which will be, I'll define that. So Here it will be becoming P2 is equals to N1 plus N2 RT by V plus N1 plus N2 square RT B upon B square. Now where B N1 plus N2 whole square B is equals to N1 square B11 plus 2N1 N2 B12 plus N2 square B22. So P2 will be equals to, so that equation I have already taken as 1. P2 will be equals to RT. Now we are seeing pressure change dP equals to P2 minus P1. So subtracting equation 1 from 2 equals to RT by V minus N1 RT by V. Okay, so this is an equation plus N1 square B11 plus 2N1 N2 B12 plus N2 square B22 by RT by V square minus N1 square B11 RT by V square. So dP will be equals to 2 minus P1 equals to 2 RT by V plus 2N1 into B12 plus N2 square N2 N2 square B22 RT by V square. So taking this dP as dP equals to delta P. Okay, let us try solving that. Taking solving for B12. So taking common so you taking common 2n1 taking common RT by V square. So this will be del P V square by RT is equals to N2 plus N2V plus 2N1 N2 B12 plus N2 square B22. Okay, now B12 will be equals to by RT minus N2V minus N2 square B22. So N1 N2, which implies B12 will be equals to 1 by 2 N1 N2 delta P square V square by RT minus N2V B22. So what does this ask? The question was asked, so we have found out this dP and all. So what it contains? It contains only B22. If you will see, there is no roll of B12. It only contains B22. B. Okay, so let us revise a bit whatever our question was. So that's what we had. So let us revise from week 1. So there was given like initial concentration management, that there was NaCl initially given to us. There was some millimoles of NaCl was given to us, and it was asking, and there was one impermeable membrane. So we have to just take X moles to be going here and there, and we have to just manage the concentration. And what we have to do, that at equilibrium concentration, we have to just equate the two concentration to concentration. So yeah, now we should know that in Donan equilibrium, solvent activity when it's 1, so it is the solute activity is basically the concentration. The main potential model which has been used, it is Lennard-Joule potential model, and we also saw that what at f equals to 0, what is the value of r. So what we did, we just equate du by dr equals to 0, because force is equals to 0, and we found out after solving and describing, we found out that r is equals to 2/1/6 to the power sigma. So we have to non-ideality for ideal gas, we have to use pressure terms, correction terms for these things to capture the non-ideality in dense gases. So the other question which we tried to do was, we had few virial equation terms, and we have to find out the second virial equation when we had given Vm at the pressure and the temperature. So what we did, we write the equation in P equals to 1 by BRT, and one equation was that that in liters per mole we were given, so we just did it for centimeter cube. So we also got to know why there is more solubility for acetylene with DMF rather than N-octane is majorly because DMF and acetylene forms a complex, and ethane doesn't have any acidic hydrogen, so C2H2 is basically this. So this is an acidic hydrogen, whereas ethane has no hydrogen at all, so that doesn't have any with DMF, and they reacts and forms a complex. We should also remember that in osmometry we use the potential of mean force to calculate the intramolecular interaction. And there is a 3-parameter corresponding state theory which take part the pressure, TR, and the VR terms into the parameter. Then we did that we had few parameters RA, RB values, and we had FA and FB. So we wanted to find out how much FBB when there is 2 nanometer of it. So we just used attractive potential, not the repulsive curve, because we have been given an attractive force. So what we did, we just differentiate du by dr, where we try to relate the generalized general force by an expression of constant epsilon by k and sigma by r, and then using corresponding states theory we found out that E by ak is equals to this much, and this will be beta vc square, and then we just divide the equations. We just try to divide, and we had all those value, and we put it, we got those force B approximately. The other was on the concept of virial coefficient, that there is a V terms temperature in N1 gases, and we interacted, added some another gases, like there was gas 1, gas 2, which we have already interacted, and we tried to find out that how much Bij, just how much B22 will be there. We just got to know that how much interaction term with all moles will be there. So when we calculate, we try to answer, this will be the answer we got, like it is only dependent on B22, no interaction of B11. That's it for the day. Thank you so much. I'll be uploading this lecture as soon as possible, and I will also upload my notes so that you can deeply go into it. And thank you so much for attending the class.